So first of all, I have a bit of notation in case you're not familiar with it. If you have something like sine squared with the 2 there, that means the same thing as the sine of x all squared. The reason that it's put in the middle there is if I went like this, which one would I mean? Do I mean the sine of x squared, or do I mean the sine of x all squared? So the convention that's used is that when I put it in the middle here, it's this one that I'm referring to. The whole thing is squared. Okay, so it's you're going to see it lots, but anyway, just to get it out of the way, when you see it in the middle, it's the whole thing we're squaring. So we're going to go back to solving trig equations, but now we're going to throw in the quadratic part of it as well. Okay, so this time, if I have sine squared x is minus a quarter equals 0, I'm going to have, just like we did last day, rearrange this. Oops, equals 1/4. And now how do I get out of this and into what we did last day with just without the square? Yeah, square root. So you're going to go like this. Any problems? Excellent, right? This is one of those places where it's a common careless mistake to make. Plus and minus needs to be in there, otherwise you're going to miss some of the answers. Okay. So what I'm looking for this time is where the sine of x is equal to plus or minus a half, which means when I go to find my angles, there's going to be 4 things. There's going to be plus, that's where it's positive, and there's also going to be the minus down here. So go with the picture again. That'll help remind you where you're looking for your answers. It'll also show you, oh yeah, I'm looking for 4 answers, not just 2 this time. Okay. So what triangle out of my special triangles has a half in it, or somewhere in the triangles? There's a 45, 45, a 30, 60, 90, and then there's the unit circle. So yeah, the 30, 60, 90 triangle. So it sounds like you're starting to get familiar with them, which is excellent. So this is root 3, 1, 2. This is 60. This is 30. So our units here are in radians. I'm going to keep working in radians as well. So even though this triangle is in degrees, I'll refer to my answer in radians. So if it's a half, I need the opposite and I need the hypotenuse. So here's the opposite angle. It's 30 degrees, or pi over 6. So my reference is pi over 6. So then I can figure out what these angles were supposed to be here. So the first one is as you see it. This angle right here is just pi over 6. Then as I move over to the next angle, if that's pi and I back up by pi over 6, the next angle, this thing is really sticking today, yeah, is 5 pi over 6. And then from pi over 6 I go one more, or sorry, from pi I go one more, which is pi over 6. Extra gets me 7 pi over 6. And then finally on this one, this is 2 pi, and I'm going to back up by pi over 6, so I'd be at 11 pi over 6. Okay, so all 4 of these answers will solve this equation here. That's the twist today, now that we're working with the quadratic equations, is that you may see more than just the 2 answers that you had last day, so be careful of that. So you guys take a look at the next one and see if you can... Oh, question? Are these answers, are these supposed to be negative? Is that the question? Well, the range is from 0 to 2 pi. Right, this is the domain that I'm working on here for my, right there for my answers. So my answers will be positive since that's where I chose. Okay, so you guys give the next one a try to see if you're getting the hang of this, and I'll pause here. We'll recap together. Okay, so I think that's probably, you're probably there or you're waiting for a bit of help. So I'm going to be looking for where the cosine of x is plus or minus 1. So this one doesn't apply to a triangle. It's going to apply to the special, sorry, no, oh, sorry. Okay, I think you guys should have a view of it. This one applies to the unit circle. So I need to be, where's the cosine of x equal to plus or minus 1? So how do we use the unit circle when we're dealing with cosine? What is it we're looking for? The x-coordinate, in this case, the x-coordinate is plus 1 or minus 1, which tells me that x could be 0 or pi in order to make this equation work out. So you probably remember this from Math 11, which was that when you had quadratic equations, factoring was one of the strategies that you used in order to solve them. And that's what we're going to add now to our trig equations. So let's pretend that we already know how to factor these equations, and then they would look something like this when we're done. Do you remember how do you deal with a factored equation? When it's like this, factored equal to 0? Sorry? Yeah, so it might have been like first semester last year that you did this, but basically what we're going to do is we're going to take each piece. If I make this piece equal 0, oops, sorry. If I make this piece equal to 0, then 0 times anything else is 0. Or I could make the other piece equal to 0. That'll solve the equation like we did last day. So again, you're going to probably end up with more than one answer here, or sorry, more than the standard 2 answers. But we break it into pieces. So I'll walk you through the 2 sides here. This is the same style we dealt with last day. I'm going to be looking for where cos x equals 1. That happens right there when x equals 0. When tangent of x is equal to 1, that actually lands on a triangle, not the unit circle. Do you remember which triangle is gonna? Yeah, this is like 1 over 1. So I'm thinking about this triangle where it's 1, 1, root 2. That's a terrible 2. Root 2, and then there would be 45 degrees or pi over 4 in the corners. Okay. So that means I can find my angles where tangent is positive. Pi over 4 will be the reference. Oh, and actually, sorry, I guess I'm making you work harder than you need to. We're in degrees on this, so we'll stay in degrees then to answer this question. So it'll be 45 and 45. So one of them is fairly straightforward right here. I can find x is equal to 45 degrees. If I'm in that interval, what's this angle? 225 is correct. However, 225 is not in that interval. You need a coterminal angle. You're in the right spot, you're just in the wrong range. Yeah, negative 135. So the way that you're going to move is this is negative 90. This would be negative 180. So I'm going 45 degrees ahead of 180. So it'd be negative 180 plus 45 gets me to negative 135 degrees. Okay, so that was correct. Okay. So in the next example then, again, I want you guys to take a look. Try from the beginning. You're going to look at each piece and find the solutions to each piece. Okay, so if you hadn't looked up at the board yet, here's the solutions that I ended up with. It's still early, and you know how I can be careless sometimes. Can anybody confirm that they also arrived at those solutions? So for the first one, it's a unit circle problem. You need to figure out where the x-coordinate is 0. That happens in two places. One at the top, which is 90 degrees. The other at the bottom, which in our case is negative 90, since the interval is from negative 180 to 180. Okay. Then the second problem, when I solve, it's going to be a special triangle. The special triangle that has a 1 and a 2 in it, which is the 30, 60, 90 triangle. If I then piece it together, I find my reference is 60, and I can use that. The fact that it's negative, I know it's going to be quadrants 2 and 3 that I'm looking in. Oops. So with quadrants 2 and 3, I get 120 and negative 120. All right. So as long as we can do those things we just talked about, all that's left then is to talk about how you factor these equations. Okay, so we're not actually going to solve these ones. We're just going to practice factoring them. So for example, first I guess, are there any questions there? I know it's like 9 o'clock in the morning and you probably don't have anything else on your mind right now, especially math. How many people are still sleeping right now? Fair enough, yeah. Okay, so what I'm going to do is, to start this off, I want you to think about it like you would have done in your previous years of math. So instead of seeing all this trig stuff that you're not familiar with, the best thing you can do is get your brain to connect what you know. So rather than call this sine x squared minus 3 sine x, you could think about it like this. You could think about it as like y squared minus 3y. All I did was chuck a y where it used to say sine x squared. Now this isn't something you need to do. I'm just trying to help you see that you already know this. The way I would factor that problem is like this, right? So even though there's that trig in it now, it's going to work out the same way. It's going to be sine of x times sine of x minus 3. Okay. So the next one is trickier, right? It's not going to factor quite the same way. But again, I'd like you guys to work on this one. Pretend you're dealing with this. If you have a hard time working with the trig right now because it's brand new, this is the same problem you did last year, but now we're doing it with cosecants or sines. So think about it this way and give it a try. Okay, so if you remember this in Math 11, what was your strategy? You play a little game, right? You say, I need to find two numbers. Yeah, they add to negative 3 and they multiply to negative 28. So that means you probably would go like this. Okay? But this year you're using the trig ratios. So instead of it being y minus 7, well, how did I end up with x minus y there? Oh, so it should be x plus 4. There's that better? All right. But instead of using the y's, what you're thinking of this year is you're going to be working with cosecants. So it's going to be cosecant x minus 7, cosecant x plus 4. Now the last one I probably need to work with you a bit on. Now this is the weird one because depending on who your teacher was, you all have different ways of dealing with this. And you can, whatever you're comfortable with, you can continue to use. I'm telling you, over the years, I've probably seen a dozen different ways. The way I do it is the one that I think for myself is the easiest. The only pitfall is there's a careless mistake. I'll show you where it happens. But other than that, I think this is the easiest way to go. So if you don't like my way, you can use your own. But this is the one where I start by multiplying that first number on the end. So I'm going to have cosine squared x plus 7 cos x minus 14. 8, yep. I multiplied the wrong 2. I was looking at these guys, I guess. Whose idea was it to have math first block anyways? Has anybody seen this technique before? Some of you? Okay. So then what I'm doing is I'm going to factor this the way I normally would, and now there's no number in front, so it makes it a little easier to work with. I'm going to have the cosine of x minus 1 and the cosine of x plus 8. So that's the pair I'm looking for. Now this is the careless mistake that you see in front of you right now. So be careful, because it's already factored. A lot of people are like, oh, awesome, I'm done. But you're not. You made this change up here, and we have to account for that. The way we're going to undo it is we're going to end up then dividing out that 2 we multiplied in. So what I'm really going to have here is the cosine of x minus a half and the cosine of x plus 4. Whatever fraction you have left over that does not reduce, then what you can use it for is to reconstruct the original. The original would have been 2 cos x minus 1 and cos x plus 4. So you can verify that this does in fact expand back to where we started. You can verify that. But now that it's in factored form, I could go and solve it like I did with the other examples we've worked on today. So I'm not going to spend any more time on our video here with this, but you need to know that that kind of factoring is something you're responsible for. If you have your own technique, go for it. If not, you need to be comfortable with one of the possibilities. So these are more like the factoring questions that you're going to need to work with. So this time I would like you to start the process right from the beginning. Factor it, solve the pieces, and come up with your solutions. We're going from 0 to 2 pi here this time. All right, so I know this process is a little bit foreign because we're just starting it. Again, the way I'm thinking about this in my head is it's the same thing as this that I would have worked on last year. So go ahead and solve it this way if that helps you to get started. But the way it should have come up factored is you would have sine of x times, oops, having some pen trouble, there we go, 2 sine of x minus 1 equals 0. So the pieces I'm working on are going to be the sine of x equals 0 and 2 sine x minus 1 equal to 0. Now hopefully you're starting to recognize these exact values and that you know that this one here is going to be on the unit circle. And I'm looking for where the y coordinate is 0. So there's 2 places that that's going to happen. So my references, well, I guess in this case my answers are going to be 0 and pi. I'll just move this down. And then in the second equation, I'm going to end up with sine of x is equal to 1/2, which we're going to want one of our triangles. And it's a positive angle, so where I'm looking for is quadrants 1 and 2. So I just have to figure out what the reference is where it came from. If I've got an opposite of 1 and a hypotenuse of 2, the opposite would have been from 30 degrees, which for us is pi over 6. So then we can reconstruct. That's pi over 6, and this one will be 5 pi over 6. So those are the 4 answers you should have for this first example that requires factoring. Okay, can I just get a sense of how we're doing so far? Hands up if this was, you were okay to follow this from beginning to end. Okay, so we'll go through another one then here, and then I'll let you try the next couple. If you're already going ahead, please do, but I'm going to walk through this next one slow with the class again just to make sure that we're on board. So again, like the equations you would have worked on, we want to solve it for 0, right? Because we have to use that idea that if we factor everything out, we're going to have the pieces that multiply to something equal to 0. So this is the first thing I would do. Then I'm going to factor out cosine. Now that it's factored, I have two pieces that I'm going to try to solve. One is where cosine of x equals 0. The other is where sine of x minus 2 equals 0. So cosine of x equal to 0, that's a unit circle problem. This means I'm looking for where the x coordinate is equal to 0. And that happens at pi over 2. And 3 pi over 2. Now here's the great thing about some of these equations. You come to the next one and you want to know where does sine of x equal to 2? Well, if we think about what the sine is, it's the opposite over the hypotenuse. What do you know about the hypotenuse? Well, just any hypotenuse, not just the unit circle one, which is 1, but what do you know about... it's always got to be the longest, right? It has to be the longest. So is there a triangle where the opposite side is 2 and the hypotenuse is 1? No. So that means there is no answer here. We can just reject it. Gone. Okay. So it's not going to work for the sine unless you're between -1 and 1. Once you get out of that realm, the hypotenuse is no longer the biggest side. It is no longer a triangle that we will work with anyways. Okay. So there's 2 more for you to try. I'm going to let you guys go ahead with it. I'm going to come around and see how we're doing. So the question, if you didn't hear it, was can we just divide by cosine of x? And the answer is maybe. The reason you don't want to do that is you're going to lose information when you make things disappear from the equation. So for example, if you divided out cosine, then the equation would look like this now. You know what? It's a good enough question. I'll start it again down here. So let's just say we went sine x cos x equals 2 cos x. And we thought, let's just divide out the cosine. So those are gone. And I end up with sine of x equal to 2. And you say, oh yeah, Mr. Joyce said there's no solution there. So I'm done. But you notice that by removing cosine from the equation, we lost these answers here. So that's why you can't make things disappear. Later, we're going to talk about how you can change them, but you can't take them out, right? So if you do something that makes it disappear, you're going to lose parts of the solution as well. Okay, so excellent question. Okay, so if you're working on the second one, go for it, but I'm going to work on this one here. Oh my god. Keep hitting that space bar. There we are. Okay. Tan x sine of x plus 1. Okay, so tangent of x equal to 0. There's a tricky one. Right away you should say to yourself, well, I know that this cannot be a triangle because it has a length 0 in it. So we're going to have to run to the unit circle. But how do we've been talking about cosine and sine so far on the unit circle. How do you figure out where tangent of x equals 0? Right, so definitely want to remember that it's y over x. Right? So how do I make it equal to 0? Yeah, that means when y equals to 0. Or you could also think of it as where the sign is equal to 0 since they're connected. So remember, the way you make a fraction 0, like for example, my bank account has 0 out of $1 million in it, right? It doesn't matter how big the bottom is. If you have nothing on top, then you have nothing overall. So to make this tangent of x equal to 0, I'm looking for where the y coordinate is a 0, and that's going to be these two positions here. So x is going to be at 0 and pi. Then the other one is also going to rely on the unit circle. I'm looking for where the sine x is equal to -1. So here's my unit circle, and the y coordinate is down here, and that's when x is 3 pi over 2. So I have 3 answers to this problem. All right. So again, to be clear with my expectations, this is the mother of all trig questions. If you can get to this one, I don't believe there's anything that you'll have any troubles with, because this uses the last couple of lessons we've done. If you walk through this and you're good, you're really good at trig, okay? That's the top of the Everest, which is trig equations. Okay, so if you haven't already tried it, see how you do with it. Okay, so the technique that I'm going to walk through might not be the same one you did, but here's how I would factor this problem. Any problems? Awesome. Okay, that's the pitfall, remember? This is what happens when students go on autopilot. They hit this, they see the equations, they just start solving, which is not going to work in this situation. I forgot to do that division I told you is necessary if you factor with this method. That divide by 2 has to be in there, or you're not going to get the correct answers. You're going to have different equations. So what I'm going to end up with is the sine of x minus a half, and the sine of x minus 1, which would give me these equations: 2 sine x minus 1 and sine x minus 1. Okay, so if you survived that part of the factoring, you're in good shape. That's probably the hardest part of this task, because now you have the equations you've been working on for a couple of days now, where 2 sine x minus 1 equals 0. Which is going to be where sine of x is equal to a half. And it comes out of this triangle. So my reference is going to be 30 degrees, or pi over 6. And I am running out of a little space here, but I think I can squeeze it in. Sine of x is positive. It's going to be these two quadrants where I find it. So these are the two angles I'm looking for. One when x is pi over 6, and the other when x is 5 pi over 6. Then the other equation, which sort of ran out of room for, I'll put it over here, is the sine of x minus 1 equals to 0. So I'm looking for where sine of x equals 1. That's going to be a unit circle problem. I need to know where the y coordinate equals to 1, and that happens when x is pi over 2. Okay, so how are we doing, gang? Did anybody climb the Mount Everest of the view from the top? Can I just see? Let me give me an idea. Oh, brilliant. Okay, you guys are doing awesome. if you're not quite there yet, don't sweat it. This is, like I said, this is one of our Mount Everests when we get to this course. So the only thing we haven't talked about is the general solution. Works very similar to last day. It's just that now you have more answers. And why don't we change the interval on you? So this time we're going from negative 270 to 90, and you can answer in degrees. Okay. So here it is. You can answer these two questions. You can do the general solution, and you can do this range. You can safely go to bed tonight knowing that you don't need to practice trig equations anymore. Okay, so give it a try. Check with your neighbor. Make sure you guys agree. Okay, so here is our first solution. You can reject the cosine of x equal to 2. It does not happen. Then the second one is where cosine of x is negative 1. Oh, sorry. There. Sorry, I forgot to unfreeze it for you. So the cosine of x equals to negative 1. That's on the unit circle at minus 180 degrees according to the range we're looking at. If we're going from negative 270, it's going to go 0, negative 90, negative 180, negative 270, and then it would go 0 to 90 degrees on this side. So it'd be negative 180 is the one I'm actually looking for. And if I wanted to give you a general solution, meaning all possible solutions then, it's just doing the coterminal dance. Add 360 each time, and you'll end up back at a new solution. Okay. Now, this tangent question that we have here, there is one thing that I even see I made a note to myself. I said, be careful, and we weren't careful. This question came off an old provincial exam that just about every math teacher went, there must be a mistake in the key. Why did everyone get this wrong? Because we all did this, and we forgot one important thing here, and that's that what's the value here? When I'm on 3 pi over 2, that's the point 0 and negative 1, right? And and tangent, rather, takes on the value of y over x. So what happens if I put this value into tangent? Some of you are saying it. If I put 3 pi over 2 into tangent, it's going to be the same thing as negative 1 divided by 0, right? So that one's not actually going to work for this problem because you'd have to divide by 0 to do it. So that was the be careful part. For tangent, the tangent at 3 pi over 2 would be negative 1 over 0, and that's not possible in order to give us an answer. So in this case, we'd have to reject it from our list of answers because we divided by 0 in order to get it. Okay. So apologies. Let's take a look at the last one here, which is tangent squared theta minus 5, tangent, all that kind of stuff. Here's how we can factor it. So tangent of theta, this one I can do. If I want tangent of theta to be equal to 1, Hopefully you recognize this one too. That's the triangle we're dealing with. And because it's positive, that means the tangent is going to be in quadrants 1 and 3. So 45 degrees is my reference, and here is going to be 45 as well. So on that interval that I have, what angle is this one here that I'm about to highlight? Yeah, it's just 45. So one of our answers is 45 degrees. And what's this one? Good, negative 135. All right. Now the last equation we have to look at is tangent of theta minus 4 equals 0. So is it possible to solve where tangent of theta equals 4? So tangent is opposite over adjacent, right? Is it possible that you're looking at a triangle where the opposite side is 4 and the adjacent side is 1? Sure it is. Let's try. That fits the bill, right? That triangle does exist. Tangent's different, right? Because tangent doesn't have the hypotenuse in there, so it can be bigger than 1. That's okay. So we don't have a special triangle for this. You don't need to make a special triangle for this. If it's not in there, there was another technique we did last day. Do you remember? Calculator, right? So that's how we have to do it. We don't have a special triangle for it. We're going to have to use our calculator, which, you know, as long as you don't forget that that's available to you, it's kind of easier, right? Because the calculator is going to give you, oops, sorry. The calculator is going to tell you what the reference angle is for this. So what do we have then? Remember, you got to be in degree mode right now since we're using degrees. Can somebody round it to 1 decimal for me? Okay, so the reference angle I get is 76 degrees. And again, I'm looking for where tangent's positive, so it's these two quadrants. I'll have 76 degrees here and 76 degrees there. So this angle is 104 degrees, while this angle here is 76 degrees. So that should be negative 104. All right, so these are my 4 possible solutions. We could write out 4 different answers, but one thing, like we said last day, is if it's on a straight line, your general solution can be simplified. You don't have to go 360. We can do it every 180 instead. Because, for example, if you add 180 to this, you get 76. You're going to keep landing on the angles every 180 degrees. So you could do it with 4 answers, but in simplest form, I would write them like this. 45 degrees plus 180 degrees times n, or 76 degrees plus 180 degrees times n. And the most annoying thing in Math 12, where n is an integer. So that will cover all possible answers, even though I've only written 2 of the 4 down. All right, so that's the end of the marathon, which is trig equations.